Welcome to clickmyproject.com. Title of the project is Selecting Spatiotemporal Pattern for Developing of Parallel Applications. Patterns of parallel computing attempt to make a field accessing to non-expert by generalize the common techniques. We propose the spatiotemporal partition strategies. We are using the four types of partitions: STP, SIP, and partition tree and the radar process. We are using the spatial data. The data was in the water level of the data we have mentioned to the spatial data. Taxonomy that describes each of resulting four partition strategy and present a three-step methodology for selecting one or more given throughout and latency goal. The STP means the spatio data partition, spatio instruction partition, and radar process tree and partition tree. These case studies cover several simple examples as well as more complicated applications include the radar processing application. Addresses the need of the pattern selecting methodology by presenting four pattern and accommodation decision framework. We have using the spatiotemporal, we have using the correct dataset of the project. We have taken to the water level of the dataset we have using. Using data that we have the latitude and longitude updations. The data are not only static updated. Each and every state-wise we have changed to the each and every years. We have the collection of the state data set, the log, huge data set we have. So we have the maximum part of the spatial and partition for the trees. The partition will be divided for four methods. We have using to the tree basis, we have seen to the partition tree. Let us see the flow chart. First of all, we have the data and extract the database. Uploading the data and extract the data. Data extraction will be success for the data set. Will be successes, we get the result. And suppose the data extractions will be failed for some more resolutions, some more extraction part failed. We have mentioned the failed extraction. Main part of the data flow. The data and the partitions. The data are using for the water level spatial data. The spatial data mentioned for the latitude and longitude position and well depth, a lot of the collections of the water level in the state wise. We have the partition we have mentioned to the check wires, the four type of partition we have using, the STP, SIP, partition tree and radar process. We have the STP means the spatio data partitions. We have included the data partition with the divided for the two types, only the data partition and again to the task partition. The SIP is instruction partition. Instruction means the water level of the latitude positions, and we have mentioned to the state phase what are the level of the well depth and the water level of latitude depth. We have mentioned in the water level each and every year we have changed to the data. So the radar processes are circumposition to the data. So we have mentioned the water level will be modified to each and every time. Partition T we have mentioned to the 4 divided for the area. So we have divided to the area for forms. Each and every area we have divided to 4 parts. We include the spatio ratios. We have water level. We have including 4 different types. So the spatio data analyzed to the 4 different type of data each and every time. So you locate the one area we have divided to 4 types, and another type we locate the divided to same 4 type. In-depth process. Finally, the radar process. We have using the radar process and analyze the data will be moved. So we have analyzed the data each and every time we have the move, and concurrently the origin part will be receive the data. Let us see the project demo. Open the file, click the spatiotemporal, extract the file, then click to the view part. The spatial data will be the extract and stored to the database. In this is state wise. We have the state is multiple states we are using. Huge data are there. This is state ID. The state ID each and every time you have changing that one. The FIPS and the latitude depth measure minute per second, latitude depth minute per second, and well depth part, and the sample data from where the data from the sample time, as the asynchronous time, latitude depth or longitude depth, the serial number. Lot of the depth part we have using that. This is the spatial data we have extract and stored to the database. Click the next. We have the STP and SIP position tree in the radar process is main. The 4 divided partition we have mentioned. I click the STP. STP means the spatio data partition. The 2 type of the partition we have mentioned: data decomposition and task decomposition. Data decomposition. We get the state wise. We have analyzed for the well depth. I check to the MA. The depth wise, we have a lot of the depth wise there. This is the empty spaces. We have the depth in not analyzed to the spatial data, so it's not a empty one of the data. Click the analyze part. We have know about the MA or 25th well depth or the area. So we have easily the spatial data analyzed to the well depth for the longitude position and latitude position. What are the state? MA state. We have the state ID. The different state ID we have mentioned to the different year. Know about the data for the sample date. We have the 15 August 86, we have 1586, but we have the April 89. We have mentioned that the well depth minute per seconds will be changed, or what are the calculation part will be mentioned that. So the same level of state, we have the well depth part. We have mentioned the longitude position for each and every times we have changed the longitude. We have mentioned the any one of longitude position. We click the longitude position. So we have the analyze for the MA procedure. Lot of the MA state, we have the data speed, longitude position will be changed. If using the longitude mapping for the graph, we have checking to these conditions. Click the longitude map. The position of the depth position in the MA process will be increases and decreases position. The C1, C3 the different type of the longitude positions for the state. So this position we have increasing the well depth for 50. We have decreased to the level, and we have decreased to the state wise, and we have get the increase for the 100 level. Also the C1 we have mentioned to the longitude position will be changed, or the higher level to lower level we automatically change the process. Next, check to the longitude position for the MA. Click the longitude position, longitude mapping. The longitude mapping generated for the chart format. We have the establishment for the 0 to 10 level. Between level we have traveling the data will be changed on the level. This level we have increasing, so almost the next the data will be increases. This level we have easily considered the longitude position and well depth position will be changed on year by year, and the depth will be changed on every time analyzed to the data. Next, go to SIP. This is from 2 level. We click the 60. And the 2 level we have the maximum part of the 99. So we have checked the long part. The longitude position will be check out that the longitude position there we have checked easily to the longitude position. The longitude and longitude positions whatever level to change the sample date wise, whatever the level, the analysis report for the date wise very important to that. So this difference between the instruction part. So the same procedure for the longitude level we have changed to the level for understand to that level. We are not using the chart level because we have the date wise is easily mentioned to the longitude minute per second. So we have easily water level we have used. Next, go to the partition tree. With the partition tree, the radar process will be the partition city using for the 4 divided part. So we have just to click the frame, we have divided to the 4 parts the area. Next to the data analysis, we have using this 4 part mentioned to the 4 area. The radar spatial partition we have mentioned this area will be divided for 4 lines. So including this level for divided to the 4 lines. This is including for divided for 4 lines. So we have mentioned in 4 and get the 8 and get the multiple lines we have getting. This is the one of the area. The radar process or water level partition will be changed for the 4 levels. So this is one of the part. We click that, this change to the 4 level. So each and every part we have mentioned that 4 divided partition tree we get it. This is the data analysis to what are the procedure for tree analysis in your chart. We have the data analysis separate for the 4 partition tree. So the 4 divided partition when mentioned to the graph basis. We have using the tree basis. We have mentioned 4 divided data will be analyzed that. Next, go to the radar. The radar process. This is the radar process using for the DLL, and we have using to the radar process the analysis the data will be increases. The origin point that only. So the origin point we have data will be moved each and every time the spatial data analyzed to the each and every time ratio. Finally, we have to the origin part we have receiving the data. This is the radar process. Thank you.